Following the launch of America's first satellite, Explorer 1 in 1958, U.S. space technology matured rapidly. Launch Complex 17 was built for the Air Force's Thor Missile Research and Development Program in 1956. The site consisted of 2 launch pads and 1 blockhouse. To accommodate changes, Complex 17 was modified in the early 1960s to support a host of launch vehicles. The U.S. Navy and Air Force began efforts in the early 1960s testing the feasibility of using satellite-generated radio signals to improve military navigation. After 10 years of extensive research, the services concluded that the Department of Defense requirements would be served best by a single, highly precise, satellite-based global positioning system. The initial constellation of 10 satellites was launched from Vandenberg Air Force Base aboard the Atlas missile and was called Navstar GPS Block 1.
On September 1, 1982, the Air Force staff decided to place Space Systems Operations under a separate major command and created the Air Force Space Command. Following the initial success of GPS, the Air Force planned to procure and deploy a constellation of 24 Block 2 satellites via the Space Shuttle by the end of 1987. Funding cuts reduced the planned constellation to 18 satellites and added a year to the Block 2 deployment. Following the Space Shuttle Challenger disaster in January 1986, the GPS Program Office diverted the Block 2 GPS satellites from the shuttle program to a brand new medium launch vehicle, later known as the Delta II, at Complex 17 at Cape Canaveral Air Force Station. Space Command awarded the MLV contract to McDonnell Douglas in January 1987 to meet the requirements to replenish the GPS constellation. On February 14, 1989, the first launch of the Navstar 2 GPS occurred, placing the satellite into its proper orbit, more than 10,000 nautical miles above Earth, and into the 7 pre-1985 Vandenberg launched GPS Block 1 2-plane orbital constellation. 12 Block 2 satellites were needed to give GPS its initial worldwide 2-dimensional capability. The final constellation was comprised of 24 satellites in 6 orbital planes.
By the end of November 1990, 10 Block 2 satellites had been orbited. During Operation Desert Storm, they provided navigational accuracy to roughly 10 meters in 3-dimensional space and 2-dimensional accuracy to within 5 meters. Only one GPS satellite mission from Cape Canaveral failed. The flight was expected to place the first Block 2R replenishment satellite in orbit to provide better navigational accuracy with an improved on-orbit life expectancy of 10 years. However, 7 seconds after ignition, the vehicle's number 2 graphite epoxy motor developed a 71-inch split in its casing. The split grew to 254 inches before the motor failed catastrophically, destroying the vehicle's first stage. Mission Flight Control officers sent command destruct functions, destroying the second and third stages of the vehicle and releasing the payload fairing and satellite. Both exploded on impact with the ground. Between 2,000 and 2,500 firebrands were released by the exploding gems. Another 2,100 fragments were released by the disintegrating vehicle, with 4 large fragments causing secondary explosions, estimated as high as 2,000 pounds of TNT. There were 73 people in the blockhouse when the accident occurred. A large piece from one of the graphite epoxy motors landed on the northeast corner of the blockhouse. The explosion caused damage to the protective berm, but it did not penetrate the blockhouse, although an appreciable amount of smoke filtered into the cableway. No one was killed or injured.
According to a debris study, the buildup of the berm around the blockhouse in 1991, constructed as a safety measure, saved the people in the blockhouse from any serious injury. The mishap board was not able to determine conclusively what caused the SRM failure, although numerous recommendations were proposed for verifying SRM integrity during manufacturing, proof testing, handling, and installation at Pad 17. Remarkably, the next Delta II mission was launched from the same site just 4 months later. 3 more Delta II missions were launched from Complex 17 before the end of 1997. By the end of August 2009, Delta IIs under Air Force supervision at Cape Canaveral had supported a total of 49 successful GPS launches as GPS 2R21 lifted off Pad 17 Alpha.
During this active Delta II GPS launch history, 3 Delta II missions were dedicated to U.S. military technology experiments. The first, in February 1990, carried two SDI experimental payloads, LOSAT-L and LOSAT-R. The second, in 2001, featured the Geosynchronous Lightweight Technology Experiment, sponsored by the National Reconnaissance Office. The third, in late June 2006, was the Microsatellite Technology Experiment, sponsored by the Defense Advanced Research Projects Agency, the U.S. Air Force, and the Naval Research Laboratory. 3 foreign military missions also used the Delta IIs to launch their featured satellites. 2 NATO satellites in January 1991 and December 1993, and Great Britain's Skynet 4D communication spacecraft January 1998. The Delta II launch program proved to be one of the Air Force's greatest success stories at the Cape. How it was organized.
The Air Force will be responsible for ensuring safety and environmental standards for commercial as well as military launches. Air Force Space Command organizational plan was laid out clearly at the end of August 1990. The first Space Launch Squadron was constituted from resources taken from the 6555th Aerospace Test Group at Cape Canaveral Air Force Station and became Air Force Space Command's Delta II Launch Squadron. Following the inactivation of the Eastern Space Missile Range Center and the activation of the 45th Space Wing at Patrick Air Force Base under Air Force Space Command on 12 November 1991, the newly activated 1st Space Launch Squadron was reassigned to the 45th Operations Group at Patrick Air Force Base and Cape Canaveral Air Force Station.
The 1st SLS commander had overall responsibility for launch operations and relied on a highly trained and educated team of officers and non-commissioned officers to conduct day-to-day operations at the Cape. Every Delta II launch campaign demanded the launch contractor's best efforts. Engineers and technicians measured their progress by the safe and successful completion of commonly accepted milestones under the watchful eye of company supervisors, managers, and government officials.
Booster operations controllers acted as the Air Force's on-scene representatives during booster processing operations. They were authorized to stop operations anytime procedures, safety guidelines, or security standards were violated. Responsible engineers and mission assurance technicians monitored the status of all test procedures, vehicle problems, site concerns, and ground equipment issues, also providing a go-no-go engineering recommendation to the Air Force Launch Crew Commander on day of launch. At Complex 17, the entire process came together to create the complete Delta II launch vehicle. The first stage, solid rocket motors, inner stage, and second stage were erected and mated at the pad. Electrical and mechanical qualification checks were accomplished about a month before launch, and subsystem checks continued as the contractor prepared to mate the vehicle with its payload about 9 days before liftoff. Ordnance connections and safety checks continued during the last week on the pad, and the vehicle was prepared for launch. The Launch Operations Manager verified the overall readiness of launch operations. The Facility Operations Manager was responsible for the service towers, fire control systems, electrical power, generators, fuel tanks, water systems, and other support items. They were also the final authorization for the mobile and service towers rollback and the site's closeout before terminal countdown.
Countdown operations were among the most crucial activities in the entire launch preparation process. The first SLS supervised the following operations during the countdown: first stage propellant loading, second stage propellant and pneumatic tank pressurization, launch vehicle and ground support equipment electrical systems, third stage electrical systems, solid rocket motor, first and second stage pneumatic thruster pressure, and launch vehicle air conditioning. The squadron's portion of the countdown team consisted of the Air Force Launch Director, Launch Crew Commander, Launch Operations Manager, Spacecraft Operations Controllers, Facility Operations Manager, Booster Operations Controller, Facility Anomaly Chief, and the Anomaly Resolution Chief. The Launch Director reported directly to the Mission Director and commanded the launch crew through its pre-launch, launch, post-launch, and launch abort or launch scrub activities. The Air Force Launch Crew Commander had overall command of the LCC in Complex 17. They also consolidated inputs and status from booster, spacecraft, and facilities personnel. The launch director authorized continuation of the countdown following built-in holds that occurred during the countdown. He also made the final launch vehicle go, no-go recommendation to the mission director before launch.
The Eastern Range's support requirements for all Delta II flights included radar coverage from assets on the Cape, Patrick Air Force Base, Merritt Island, and instrumentation stations on Antigua and Ascension. Cape Canaveral and Jonathan Dickinson provided command-destruct coverage for all Delta II missions. Wallops Island and Argentia Missile Tracking Annex in Newfoundland provided command-destruct coverage for northerly missions. Antigua and Ascension provided telemetry for missions not involving northerly flight azimuths. Additional telemetry support came from New Hampshire on northerly missions. Optical, film, and video support from Delta II flights required the services of 2 domes, one at Patrick Air Force Base and one at Playa Linda Beach. 2 advanced transportable optical tracking systems, 25 to 30 high-speed motion picture film cameras also captured critical views of the launch vehicle during ignition and liftoff at 400 frames per second on the pad and towers at Complex 17. 6 gems ignited just before liftoff. Umbilicals dropped away upon liftoff, and the remaining 3 gems ignited as the first 6 gems burned out, just about 1 minute after liftoff. The first 6 gems dropped off the vehicle a couple of seconds later, and the remaining 3 gems continued to thrust until they burned out and separated from the Delta II about 130 seconds into the flight. The Delta II first stage engine cutoff occurred about 260 seconds after liftoff.
MECO, and we have MECO. MECO looks normal. Vernier continues to burn.
The first stage separated from the vehicle 8 seconds later,
Stage separation.
and the second stage ignited soon after.
And second stage ignition. And ignition looks normal.
The payload fairing was jettisoned during the second stage's first burn, which was completed around 11 minutes into the flight. Following a coasting period, the second stage restarted and continued to thrust for about 20 seconds. Then it coasted along until it separated from the launch vehicle. The spacecraft separated about 2 minutes after the third stage shutdown, and the payload was injected into its pre-selected orbit. While most launch operations might appear smooth, controlled, predictable, and unhurried on launch day, the lengthy process of getting Delta IIs ready to launch highly complex satellites into space was a complicated and often frustrating undertaking. Some launch campaigns were inherently more difficult than others, regardless of how many or few people were assigned to each of the squadrons and groups at the time a particular vehicle was launched. Bad weather, safety concerns, launch vehicle problems, and tardy payload deliveries could have a significant impact on the length of time it took to complete any mission. Sometimes, several missions featuring the same type of payload or launch vehicle could be delayed by a single anomaly or hardware defect.
GPS 2-3 was delayed 24 hours after Pad 17A suffered a lightning strike. Officials scrubbed the GPS 2-5 mission on 10 December 1989 due to a helium problem in the vehicle's second stage. Officials scrubbed the GPS 2-7 launch on 21 March 1990 due to unacceptable upper-level wind conditions. GPS 211 mission was scrubbed due to the loss of a satellite communication link with the range tracking station. And again for heavy cloud cover. Officials scrubbed the GPS 216 countdown on 7 November 1992 due to a vehicle misfire. And they scrubbed the mission's next countdown on 20 November due to weather constraints. The GPS 217 mission scrubbed on 16 December 1992 due to a vehicle anomaly that occurred during final liquid oxygen filling. The second countdown on 18 December 1992 was successful, the 17th in an unbroken series of successful missions for
Commentary with the
GPS.
successful launch of an Air Force Delta II rocket carrying the
The Tu-19 launch scrubbed on 18 March 1993 when high winds prevented removal of the mobile service tower. They also had to scrub the second launch attempt due to air conditioning problems on the launch pad. Tu-21 was put on hold for thunderstorms and lightning. In the meantime, 4 intruder aircraft were detected in the launch danger zone. And sport fishing boats from a local tournament wandered into the launch danger area about 10 minutes later. Officials extended the hold at T-minus 4 minutes to get both types of unauthorized craft out of the area.
Hurricane Floyd threatened the Florida coast, so protective measures were taken to minimize the effects of this Category 4 storm on GPS 2R3. The contractor secured both of the Cape's Delta II launch pads, locking the pad's mobile service towers in place and raising them off their wheels for stability. The GPS 2R3 spacecraft was stored in its transportation canister inside the Discus processing facility until Floyd passed 110 miles east of Cape Canaveral on 15 September 1999.
Water contaminated the spacecraft, and the original GPS 2R3 satellite had to be removed and replaced with an entirely new satellite. The GPS 2R3 was refurbished and launched as GPS 2R21. Spacecraft problems also delayed GPS 2R missions for several months in 2003 and 2005, but the long-term success of GPS program was never in doubt. 14 more GPS 2R replenishment satellites were launched from Cape Canaveral over the next 9 years, from 2000 to 2009. On 30 June 2005, the 45th Launch Support Squadron was activated to supervise spacecraft processing and provide group-level mission support to the 45th Launch Group. Put simply, the 45th LCSS activation was designed to integrate the 45th Launch Group's payload activities under one roof. Consequently, the first SLS's 6-member spacecraft flight was rolled into a new squadron. Beginning with the GPS 2R14M mission in late September 2005, the first of 8 modernized 2R spacecraft were added to the constellation to enhance GPS capabilities as never before. The 7th in the series, GPS 2R20M, was launched successfully from Pad 17 Alpha in March 2009. Additionally, the launch included a payload to secure the L5 bandwidth for follow-on GPS operations. The final Air Force-sponsored Delta II mission was the GPS 2R21M, launched on August 2009.
The first SLS was inactivated on 18 August 2009. Regarding the future improvements in the Navstar constellation, the Space and Missile Center awarded Lockheed Martin and its associates a $1.46 billion contract on 15 May 2008 to build the next-generation Navstar 3 spacecraft. The Delta II GPS partnership launch effort remains one of the most remarkable and successful accomplishments in the history of the Eastern Range.